Question 6, a bit of genetic cross and chi-squared. So we're given some p's and we're given the alleles, big R and big Y, little r and little y. And so pretty straightforward alleles, dominant and recessive. The plant breeder thinks its new variety is a hybrid. So really we're thinking that's heterozygous there. And he crossed his new variety with one that produced smooth green peas. Right, so smooth and green. Smooth is recessive, green is recessive. So we know what we are crossing this with. Smooth, little r, little r, little y, little y. The results that we're getting are we've got some dominant and some recessive and then the mix in between. So we are getting recessives in there. So this can't all be dominant. So it cannot all be big R, or else that would just produce, dominant phenotypes. So this has got to be a heterozygote. So it's got to be big R, big Y, little y. And then we know that we're going to get some recessives showing. Gametes, some problems here. These were generally done okay. We need a big R and a big Y. Some way of separating these. I'm going to put commas. That big R could be with the other Y. The little r could be with the big Y, and the little r could be with the little y. Here, there's only one possible gamete, which is a little r and a little y. There's no need to put all the gametes in there. And then you could draw a Punnett square for this. So we could put our gametes across the top. And our gametes down the side. Don't worry about how neat your box is. So here I'm going to follow the convention of putting the big capital letters first. So big R, big Y, little y. Big R, little r, and two little y's, two little r's, and big Y, little y, and then two little r's, two little y's. And then when we look at what we've got, this is dominant for both, so that's going to be yellow and wrinkled. So we can do these. Anything with a big Y is going to be yellow. So that's going to be yellow, and there's going to be green. And then anything with a big R is going to be our wrinkled. So wrinkled, big R, wrinkled, and those are the other ones, smooth. And so our F1 genotypes, those are those. So I'm just going to write these out in here. You probably get, if you've written that table there and you've done it right, they'll probably give you the marks, but you never know. Phenotypes. So yellow, wrinkled, green, wrinkled, yellow, smooth, green, smooth. Now I put them in the same order, but the examiner can see I've linked them up there anyway, and that's a 1 to 1 to 1 to 1 ratio. Based on the results of the cross, concluded that the new variety was pure breeding. And we're doing a chi-squared. So we need, first of all, to work out our expected. These column headings, we're given the equation here. So we've got O minus E squared, and then O minus E squared divided by E. We need to calculate our expected. Well, it's a 1 to 1 to 1 to 1 ratio, but of how many? And this is a common error to get this number wrong. So if we add up these numbers, 31 plus 22 plus 29 plus 26, 108. So that is 108. This has also got to be 108. The number is the same. You know, however many we expect, well, that's how many we're going to see, but we don't know what types they are. And as it's a 1 to 1 to 1 to 1 ratio, these have got to be equal. There's 4 different things of possibility. So divided by 4 is 27. So these are all 27. And the first mark of the calculation is actually, you can get that for doing that. O minus E. So 31 minus 27. You can do these in your head. 22 minus 27 minus 5. 29 minus 27, that's 2. And 26 minus 27 minus 1. When we square these, we're getting rid of the minuses. So a minus number times by another minus number gets rid of that minus number. Again, you can do these in your head. 16. 5 times 5 is 25. 2 times 2 is 4. 1 times 1 is 1. You need your calculator for this next bit, which is dividing the O minus E squared divided by the E. So 16 divided by 27, which is 0.593. 25 divided by 27, 0.926. 4 divided by 27, 0.148. Then 1 divided by 27 is 0.037. And then this sign here means add these all up. So we've got 0.593 plus 0.926 plus 0.148 plus 0.037 is 1.704. So 1.70 maybe there. The mark scheme is wrong. They've switched these around, 1.07. So if you've got the mark scheme, you're frantically trying to get to that number, it's wrong. So now we've got our calculated value of chi-squared and the probability table. And there's a question here, whether the plant grower's conclusion was valid. So is the plant conclusion valid? You need to answer that. A lot of people haven't answered that and just gone through the motions down here. And one of the marks is for saying whether that's valid or not. And so what we need to do now is choose our degrees of freedom. Our degrees of freedom is the number of classes minus 1, so there's 4 classes, minus 1, that's 3. Our confidence and probability level is 0.05, which is 95% confident, which then leads us to 7.82. So there's a mark for the critical value. So critical value, even if you put it on your table, I'd write it out. Critical value is 7.82. Our chi-squared of 1.7 is less than the critical value of 7.82, and that's going to be a mark. And so now we go, well, if it's bigger we'll be able to reject the null hypothesis, so we must accept the null hypothesis, and the null hypothesis is there's no difference between these observed and expected. So I'm going to write that in even though you don't need it. So so we are accept null hypothesis. So there's no significant difference between the observed and expected. So that means that the grower's conclusion is valid or correct. Any deviation, this is the last mark, any deviation, and there is deviation, should all be 27, shouldn't they? So any deviation is due to chance. And that's your 12 marks.